Hello there. I'm here to, you know, keep recording some videos for the channel. Today, I will not be going to um do some videos like I was going to do before because I just want to talk. It's been quite a while since I've talked with you guys. Oh my my um how how is that called in English? I've got no idea. I forgot completely. I forgot. My dress. Wait. I'm searching for how I can call that in English. Let us see. But as I was saying, today we are going to study some math. Wardrobe. Wardrobe. Armoire. Yeah, that's a wardrobe. So the door of my wardrobe was open. But as I was saying, today we are going to study some math, some mathematics, more specifically some geometry, because I'm studying through this book here, Euclidean Geometry in Mathematical Olympiads. And that's pretty much it, what I'm going to do now. I hope you guys are having a great time today. You probably can hear that there is some noise out there because my city is very there is some parties going on in my city, so it is very full of people, and people are getting some loud music out there. That's why you may hear some noise there. Well, I'm right now. Oops. Oh, unfortunately, I've let some things fall here. Let me take them. So, I'm going to put this. I don't know how to say it, boina in English, but I'm going to put this boina here. I'm solving a problem, which is this one. I don't know whether you guys are going to be able to understand. Lemma 1.17, reflecting the orthocenter. Let H be the orthocenter of a triangle ABC, as in figure 1.3b. Let X be the reflection of H over the line BC, and Y the reflection over the midpoint of BC. Show that X lies on ABC, or better, the circle that goes through ABC, and also shows that AI is a diameter of the circle that goes through ABC. So I've solved this particular question here, this particular problem. Yeah, I've written already the solution of the first item, but I ought to finish writing the solution of the second item. So let's go then. Solution to B item. I have already found the solution, but now I need to write it properly, because here it's just a draft, you know? So I'm going to write it properly. Yeah. All right, so notice that for solve the problem, we must prove two things. First, we must prove that Y lies on the circle that goes through ABC. And secondly, we must prove that AI is a diameter. Okay, so how I'm going to prove? Yeah, so let's start by the first. Yeah. So let us start by proving the first. All right, so how could I prove the first? Notice that to prove I lies on ABC, we ought to show. No, actually, I've got a better way to say it. Notice that I lies on ABC. It's equivalent to say that A, B, C, Y, no, A, B, Y, C is a cyclic quadrilateral. Yes. Notice that y lies on ABC is equivalent to say that ABYC is a cyclic quadrilateral. Yes, so or yet y lies on ABC is equivalent to say that BCXY is a cyclic quadrilateral since we've already proved that X lies on the circle that goes through ABC. Okay, so we have that. I need to prove some things here. Wait a moment. BYE. Yes. Let me think. How? Because P how am I supposed to prove that? I've forgotten. Yes, that's pretty much it. YAB YB YXB. Yeah, that's proof. That proves this. Or yet that AXYB is a cyclic quadrilateral. That's true. So if we prove that, we solve the first problem. Let O be the center of the circle that goes through A, B, and C, and let us analyze the figure. I think this dissertation, like this, this written solution is not getting very proper because I'm saying some things here that doesn't make sense grammatically necessarily. I'll close my door just some seconds. much better to think. It's less noisy now. So, this dissertation here is getting very strange because I'm trying to say what I mean, but it is not at all optimal. So, but let us continue. So, shall we continue, and then we will discover what we mean to. I want to find the other problem that I've showed. But firstly, I want to keep going. Notice that the angle CAH is equal to 90 degrees minus C by the how's it called? The triangle sum theorem. Triangle sum theorem. Yes. So let's know. All right. How does one know? How have I proved that? I've got no idea. I know that I've proved, but I do not know how. Yes. Should we see? Let me read my solution here. To show that X lies on the circle that goes through ABC is equivalent to show that the quadrilateral ACXB is cyclic. Note that by definition, XDC equals 19 degrees equals HIDC equals HDC. Notice as well that by definition that HD equals DX and CD. Note that by definition XDC equals 90 degrees, which is equal to HDC. All right. Notice as well that by definition, HD is equal DX, and CD are present in two triangles, CDH and XDC, in such a way that we have that both triangles are congruent. CDH is congruent to XDC. Thus, BCH is equal to BCX. We already showed that BCH is equal to 90 degrees minus B. BCX equals 90 degrees minus B. Thus, So, by the cyclic quadrilateral theorem, we have that CBA equals b, CBA equals b equals AXY, CBA AXY implies that AXB. Oh, okay, I've got what I want. So let's get back here. We have already showed that BXC equals to actually AXC equals to B. In the same way, we've showed that AXB equals C. Okay, that part's okay. Yes. Notice that a triangle is evident notice that H and the 2 points of intersection between BC and the lines HY and HX respectively are forming a right triangle. Notice that so yeah, this triangle is similar to the HYX triangle. Thus, HXY equals to 90 degrees. 90 degrees. I'm quite tired. I do not want to keep doing this question here. I already proved it, but I'm not finding the words to put it. So I will just do a quick solution here to move on to study other topics. Maybe not today though. 90 degrees here Thus, bxy equals to 9 degrees minus c. We already showed in the solution of another problem that ORAB equals to HAC. Thus, HAC implies HAC equals 90 minus C implies that OAB equals 90 minus C, which implies that YAB equals 90 minus C. By the cyclic quadrilateral theorem, we know that BAY equals 90 minus C implies that BAI equals 90 minus C equals BXY, which implies that BAI equals BXY, which implies that BAXY is a cyclic quadrilateral. Solving the first problem. Looking to the second part of the problem, we have that since AXY equals 90 degrees and X lies on ABC, by the how's it called? Describe it angle theorem. AOI equals 2 times 90, which equals 100 degrees, which implies that AO and I are collinear, which implies that AI is a diameter of the circle. Note to me in the future. Dear Miguel, I want to apologize for all the messy that this solution is. I found this proof, but it was quite difficult to put in the right words. Thus, I will left you with this mess. Sorry, I want to solve other problems. Bye. That's it. I've left a note to myself in the future, and I finished this question. It took me around 30 minutes to do so. I'm quite tired to write. I will not read it. I'm tired. I will just chill, relax. That's it for this video here. Maybe I will keep recording today. I'm really willing to talk. I'm practicing more my shadowing, and I need to put it into actual use. I want to become proficient in English, I really do, and the only way to become so is to talk as a maniac and to practice using every inch of time that I can find. So that's why I'm recording here this very messy video, and I will publish on my channel, so maybe someone will find it and found it somewhat interesting. So see you guys later. Bye.